right, cool. All right, here we are. All right, let's see. R.I.P. Good Times from Sequoia Capital. Okay. 2008. What else? Engineer turns plastic into bricks that are reportedly stronger than concrete. I think I've seen that video. The loneliness of a pretty good developer. All right, let's see what that is. Google open source PSP. Smart King hiring a senior ML engineer. All right, cool. I haven't seen really any news that's worth reading right now. So, state of global climate change, Moderna's HIV vaccine, technologies, integrations. Soul of Japan, introduction to Shinto and Issei Jingu. I like the wabi sabi vibes and the philosophy actually. So. All right, let's see what else we got going. 460 million internets are using IPv6. Subprime borrowers are missing loan payments. Okay, this could be interesting, actually. Wikidot has been hit by hackers. All right. Consumers with low credit scores are failing behind on payments for car loans, personal loans, credit cards, blah, blah, blah. Okay. Personal loans are at least 60 days late, is rising faster than normal. Okay, by how much? Those delinquencies rose month on month 8 times in a row, nearing pre-pandemic levels. Okay, it's just pre-pandemic levels. Okay, that's fine. Are inevitable following the decline during the pandemic? Maybe. Yeah, because everyone was like deferring their loan payments. And so now because of the decline, now that like the loan payments are going to be put back on, then yeah, everyone is going to be back to normal. So, highest inflation in 80 years. Yeah, I don't know. It's too hard to say if right now it's inflation because inflation is pretty regional. So, for instance, all the places that people move to, like Phoenix and Atlanta, are experiencing the highest rate of inflation right now because you have all this new money coming in from people who are buying. And so that pushes the cost of goods up everywhere else. But like if you look at like a place like San Francisco or like even San Jose, you'll kind of see that the prices really haven't changed. I mean, just go to your local grocery market. If you're in the Bay Area, look at your grocery market. Like the prices really have not changed that much. I think the chicken, I would say, no, chicken's a little bit pricier, but not by much. And it's just mostly it's mostly a supply issue. So I'm not actually gonna call whether or not it's inflation just yet. That is causing this subprime loans getting escalated. So stocks will rise, throw the economy back into recession. Rising interest rates, yeah. I mean, it could happen. Delinquencies on subprime car loans hit an all-time high in February. Interesting. Okay, so the subprime car loans have hit an all-time high in February. Overall delinquency is going up, back to pre-pandemic levels. Subprime car loans. Okay, well, I'm guessing everyone just bought like a used car during the pandemic times, and that was just causing this. So that kind of makes sense. Because the used car, I remember used car prices were going up quite a bit. I think everyone was just trying to buy a new used car once they moved. So I guess it makes sense. Many people, including those with less than perfect credit, paid off debts, built up savings. Yes. Auto loans, credit cards, March 2020. Yeah. So these levels look pretty normal, compared to historical averages. So I'm not. I don't know. This doesn't look like concerning to me just yet. Benefits have run out. Yeah. Higher price for food and gasoline constrains U.S. households. Correct. Yes, deteriorates ability to pay. That is true. Lenders have kept their standards relatively strict. Correct. Yeah. So you have a bunch of mortgage applications. You can actually pick and choose. It's not like 2007 all over again. I know everyone wants to talk about that, but to me, I mean, it is concerning subprime lending, but I don't know if it's a big piece of trouble just yet. I would have to read like a lot more into this, but overall, it doesn't say. I don't see anything right now. Anyway, we do have, so yeah, like just kind of give you guys a little update on the stream. So basically, someone actually reached out to reached out to me about regarding a surprise Google interview that they got going in like 5-6 weeks or something like that. And so we're gonna like just talk to him, see, and do a like coaching session, see how well he performs, and like whether or not we think we can do it. I'm gonna tell you that right now, um, if my hit rate is like 70% for a single interview across all my clients, and usually it takes me like anywhere from 6 to 8 weeks to get them ready, and in order for me to feel pretty confident about that, then basically we're talking about basically about like a 40-50% chance of success right here. It's really fucking hard. I'm not gonna lie, to get to see if we can even do this, but let's hopefully get there. I don't know, man. We'll discuss more about the situation, but it's this should be an interesting client to take on. I'll tell you this, like I have never taken on someone for on a long-term basis when they had when they had less than 6 weeks for an interview. I think M's situation was a little different because I was expecting to be able to schedule out Facebook. And I never worked with like a student before, but now I kind of have after working with him, I have kind of a sense of what it takes to work with students. And so there's like I have different expectations for that. So on top of like my normal hit rate and success rate, we're also talking about like the bias factor of like new grads and students who don't have that professional experience. So the odds are very much heavily against me. I'm not gonna lie. So let's see if we can get this done. Anyway, I'll take questions from the crowd if y'all got any. Duck chess. What the heck is this? Knowing when to punch in duck. Sure. Chess. Oh, it's a chess variant. Okay, I don't know. Pika script. Okay, ultra lightweight Python engine that can run in 4 kilobytes of RAM. Seriously? Hold up. Oh, yeah, I haven't had a chance to eat dinner, guys. So if you see me eating during the stream, that's why. Wait, what the heck? Pika P0? This is actually kind of cool, actually. Huh. This is like boots onto a Raspberry Pi. So you run the environment very specifically for that. Okay, so he has an engine that works on multiple architectures and then has an engine for one for each. All right, cool. Support and run Python scripts by serial. All right. Anyway, okay, it's 10 p.m. Let's bring on my client. Oh, and in case you guys are wondering what I'm eating, it's wonton noodles. It's from Costco. It's like those, it's like the Costco instant meals that you get from the package. So I ain't eating large, guys. You know, this ain't caviar. This is like literally fucking instant noodles. Oh, maybe he joined the Zoom. Hold up. Oh, join with Google Meet? Oh, shit. Okay, no one's here. maybe he's in Zoom. Let me open Zoom.
Recording in progress. Recording stopped.
Oh, hello.
Oh, hello. Okay.
It doesn't matter. It's Zoom or Discord. I mean, I have you on Discord already, so.
Okay. Yeah. Sure. Let's go on Discord.
All right. Cool.
Okay. I just closed Zoom.
Okay. Yeah. Cool. So what? Hey. So can you hear me?
Yeah, I can hear it. Can you hear me?
Yeah. Cool. Cool. Let's get this started. So, I have a little bit of understanding of your situation. In short, you have Google 5 weeks from now.
Yeah. Well. Yeah. I haven't scheduled. Yeah. Basically 5 weeks from now. I haven't actually finalized the schedule date, but it's expected to be 5 weeks from now. Yeah.
All right. Yeah. So. Yeah. So. Okay. So 5 weeks from now, which is about the. I say probably target date is probably around 7/1.
7/1. It's probably that's the week of, but I think they're probably aiming for June 6, 27 maybe, or something like that. Because 5 weeks from now is June 23rd. So it's just like 5 weeks and a few days.
Okay, so we're looking for June 23rd then.
That's like the earliest, yeah. But yeah.
Okay, cool. All right. Yeah. So we have an interesting situation here. So we're looking to do this in about 5 weeks. And so tell me a little bit about like how you've been practice. I think you showed me your practice diary, and I kind of gave you a little bit of feedback. Have you done like mock interviews before? How's your prep been for that?
For mock interviews, I used to do them a lot before. Recently, I haven't been doing any mock interviews. As for prep, I usually just do grokking and API for the questions.
I remember you mentioning that you have some issues with recursion.
Yeah, so I'm not really good at identifying when a question requires recursion or it's easier to solve recursion, and I sometimes, if I do have the idea, sometimes it's difficult for me to implement the idea too. Stuff like that.
Okay. I assume that you've watched the streams with M, and you're familiar with a lot of the concepts and ideas that I talked about, like, keeping your ideas simple, planning before you write the code.
Yeah.
Okay, have you tried it, like, implementing those actively?
On some questions, yes. If I like understand the question well enough, for questions I don't understand the question well enough, I usually just try and plan it, and then I kind of get tired of planning, and then I just try something that works, because I'm like half an hour maybe into the question, and I don't know any ideas, and see like just print statements and all that to see what works.
Got it. Okay. So we're basically starting from ground zero then.
Okay,
cool. You know what? Let's do this. Let's do a problem so I can get like a more accurate understanding. But I think I have an idea of what we're working with here. So.
Okay, yeah.
All right. Okay, so I'm gonna send you the link. Here is the problem sheet. Let me also send you the link to the doc as well. So this is like your prep doc.
Okay. Oh, neat.
Okay. So let me know when you're on it, and we'll get started with a practice problem.
Okay. Should I be on it?
Yeah, you're on it. Can you edit?
Yeah.
Cool. Let me pull up a problem then. And let me know if you've seen this one before.
Okay. Yeah.
Let's see. Okay, let's do something simple for recursion, because I think You say you're struggling with this. Let's do something simple.
Okay, yeah.
That was too simple. Okay. No, not this, not this. Okay, actually, no, we'll do this one, the classic one. I've given this one a lot, so let's see how well you do. Alright, and here we go. So, given a binary tree, find the lowest common ancestor of two given nodes in the tree.
Okay. I somewhat have seen this question before, but I don't really remember how to do it. Is that
Yeah,
okay?
That's fine.
All right.
Even better, because that way I can that way you should be more comfortable in your approach, but that means there's more for me to critique. So.
Okay, yeah, for sure. So let's start off. So, I guess you're gonna give me just the root of the tree, for the binary tree.
Yep.
So in this case, it would be 3, and then you also give me the pointers to the nodes, or like just the actual values in the nodes, in which case all the nodes will be unique values.
So you can assume I will give you the node of the tree and then 2 nodes.
Okay, and then those 2 nodes, I have to find the lowest common ancestor. So in this case, if you give me the nodes 6 and 2, I would return 5.
Mm-hmm. Yep.
And also in the case of 0 and 7, I would get 3.
Correct.
All right. Okay, so let me just write it down first so I don't forget anything. So if I get input as with 3 for root 3, I'll just define it as P and Q for the 2 nodes you give me. Is that okay?
Mm-hmm. Sure.
All right. So yeah, that, then Q 0. Output would be 3E.
Mhm.
So let's go for the 3 test cases off the top of my head. So basically, if the node you give me is in the left subtree and the other node that you give me is in the right subtree, from the root. So P in left subtree, Q in right subtree. Well, that's the first case anyways, so I'm just gonna copy that and put it there. Oops.
Okay.
Yeah, the other one is vice versa, Q in right subtree and left subtree. Though I don't think it matters that much, but I think it's probably something I should still consider. And right subtree. Yeah, input, same thing.
Sure.
Root 3, Q6, P equals 0. And then both in their same subtrees. So if both of the nodes you give me are in the left subtree, so in this case the example would be 6 and 2. So both nodes in left subtree. I guess the same thing is in the right subtree, but I think the left subtree will cover that test case also.
Yeah. So what do you mean by both nodes in left subtree? Left subtree.
So I'm referring when the left subtree of the roots. Okay. So it would be like node 6 and 2 you give me. Oh well, no. Okay, that's a bad explanation. So, I guess it doesn't matter then. If they're both in the left subtree, or well, how would you count the root itself also being a lowest common ancestor of the same? Like if you give me 5 and 6, would 5 also be the lowest common ancestor?
Yeah, 5 would be the lowest common ancestor of 5 and 6, correct.
Okay. So yeah. Okay. So I guess that would be what I explained as both nodes in the left subtree. Sort of thing. So root 3, yeah, what am I doing? P5, Q6. I'm gonna assume you're gonna give me actual valid nodes. to the subtree, to the the node. So like the the two given nodes are actually, given nodes, not like null or something. That don't exist.
Yeah, for now, let's assume the validity of the nodes.
Okay. All right. So, my first thought is I'm guessing the nodes will contain a left field and a right field, and a value field or data, whatever we want to call it. So like node dot left, node dot right.
Okay.
So yeah, I'm guessing. So what I'm basically saying is I'm assuming there's no parent nodes and no parent pointers in the nodes.
Wait, sorry, repeat that?
So I'm assuming that there's no parent pointers in the node. So like there's no node dot parent or anything.
No, it's not doubly linked. It's single.
Yeah. Okay. All right. So yeah, so it's a binary tree. So yeah, node dot left, node dot right. My first guess. So let's go into it, like try and figure out a really simple solution to this. Basically we either we had to traverse the tree regardless. So there's the option of BFS or DFS.
Okay.
And BFS, if we do BFS, I don't see a very intuitive solution off the bat for BFS.
Okay.
Because if we do BFS, it's basically we go level by level, and once we find one of the given nodes, we're gonna have to traverse a bunch of other. We're gonna be changing levels a lot essentially. So
Okay.
I don't think it's too good to use BFS here.
Okay.
So I think DFS is a bit more intuitive in this situation. Let's see how we can do it. DFS. I know there's post order, pre order, and in order. Does one of those help us at all? In order, so we go left first. So 3, 5, 6, then 2, 7, 4. Let's go for the first test case. So if we see a node, that is one of the given nodes. So P, if we see P in order traversal, then I guess we should return something, and also the same with Q.
Okay.
There's also the basic check for. So since we're doing in order traversal, we also have to do a basic check when we reach a null node, because each nodes have their null pointers when it's a leaf. So yeah, so that's gonna be our base chase check, I guess. So if root equals P or Q or root, we can just return the root, because if root is null anyways, it's just gonna return null. So that handles that case. After that, how do we actually make progress towards combining those two results? So what we can do essentially is we can do maybe a post order thing then, because if we're doing going left and right and we're returning PQ, then we can do something similar to finding the leaves, start from the leaves in the node essentially, and build our way up. So once we essentially find the left, find P, we'll just assign it to be in the left subtree, and Q to be in the right subtree.
Okay.
We just traverse basically all possibilities. So we'll try and find P as we traverse down left of the root and right. In the left, so P will be in the left subtree.
Okay.
And we'll recurse down the left subtree, we'll recurse down the right subtree, and if we find P, or if we find P, so basically, okay, we recurse down the left and the right subtree.
Okay.
If we find both P and Q in that, if we find both P and Q in the subtrees that we search for, then we return the node we are currently at, which is the
Sure.
root and the lowest common ancestor.
Mhm.
If we only find one of the nodes, so if we find either P or Q, then we would just return the one that's not null. And so that will handle the case where it's in a different subtree. So as we recurse, we'll go up more and more levels because we're returning something. And then eventually, the last case will be the root. And, you know, the root should technically be the lowest common ancestor of all nodes. So at worst case, it'll return the root. And the right, yeah, and essentially return the right.
Okay. Okay. I kind of get the idea, but I'm curious to see like what is going to happen here. So.
Okay. Should I, like, so do I start coding then, or
however you want to do it? However you want to do it. Pretend like this is an interview.
Okay. So yeah. I'll basically ask, like, do I have the go-ahead, essentially, for implementing the solution? Does it make sense to you, sort of thing?
I mean, there's probably a few cases you're missing. I'm curious to see what the code looks like for this, so.
Okay, yeah, for sure. So, start coding. Is it okay if I don't define the binary tree node, or...
I mean, you pretty much say there's left, right, and node.value anyway, so.
Yeah. Alright, so yeah.
Yeah, go ahead, you type it.
Oh, okay, yeah. So yeah, just... basically that. I'll put it in Python because that's my main programming language. Or would you prefer pseudocode and or something? So I'll just do it in Python then. Okay. So yeah. Okay. Basically LCA because lowest common. Actually, I'll type it out fully.
Sure, go ahead.
Yeah, okay, so, roots, you give me P, you give me Q in my test cases. So first off, the base case check. So, you know, if a node is null, or we find P or Q, like one of those nodes, essentially. So if not root, that's basically if root is equal to null, or root equal P. Actually, you're giving me the node pointer, so I should do root is P, because that's reference equality. Equal is just value equality as far as I understand. So yeah, root is Q. So yeah, and we return root here, so that covers the case if we find P or we find Q, or if the root is null, we essentially return null. In that case, I could separate this into different if cases too. Then we go here. So we assign left. We basically traverse all. We basically, at this step, we go left. And then we'll do another step for we go right. So we'll basically cover the entire subtree.
Okay.
So lowest common ancestor. Root.left. PQ over here. Same thing with the right. Lowest common ancestor, root.right, PQ. So now technically this traverses the entire tree.
Okay.
So now we have to define. Now we have to check if it's if this makes us a lowest common ancestor.
Okay.
If this current node is a lowest common ancestor. So if left and right. So basically, if it doesn't return null for left and right, then we return root. That is our lowest common ancestor.
Okay.
Else, so basically we're returning the non-null node. So if P is null, then we return Q, and vice versa. So in Python, there's a really nice, easy way to do this. It's just left or right. Python will basically return the non-null one. We already know it's only one of them is going to be only one of them is going to be non-null because we have the if left and right case over here. So that checks if they're both having nodes.
Okay, wait. So wait. Why can't left and right be null?
Oh no, left or right. It can't be null. No, like one of them has to be. Wait, no. Okay, my bad. So they can one of them either has to have a value or they can both be null,
Okay.
essentially. But they
Fine.
both can't be true. They both can't have values, is what I'm saying.
Oh, because you handled it up here?
Yeah, because I
Okay,
handled it up
okay.
here in the if left and right.
I see.
Case. So yeah.
Okay.
Yeah, and essentially, I think this is it.
Okay. So what happens if you find a Okay, I see what you're doing. You're using the root to represent
Yeah, like the lowest common ancestor.
Wait,
Because
let me
basically,
test this. Let me
yeah.
test this really quickly.
Yeah, for sure.
Okay, that's fine. Okay, I see. All right. What's the time space complexity of this?
Should be just O of n because at worst case, root is our root is the lowest common ancestor, so that means we would have to traverse the entire tree. So O of n space, I think. If you count the stack, then technically it's O of n, but you can just say it's O of 1.
Okay, but order n is order is O is average time. So you recognize order n as the worst time. What's the average time?
The average time of this?
Mm-hmm.
Average time. Does that require? I don't know how to calculate average time unless you go like amortize analysis sort of stuff.
Okay.
Average time. I guess it could be. Just like a shot in the dark. Would it be just like n over 2 essentially? No. Yeah, that's
okay, I see. Honestly, I'm still questioning. I've never seen this shorthand solution, so I'm like trying to make sure that this is actually right.
Yeah, no worries. Like, when I read the EPI solution, like what I remember doing it in EPI and it came along. I think the solution over there went over my head a little bit, so I just stuck with this one.
Okay, I see.
That's what my reasoning.
All right. Anyway, I got a few things to talk about anyway, so
Yeah,
that's
for
good
sure.
enough. So, all right, what do you think you did right? What do you think you did wrong?
My explanations were very confusing at times. I stumbled a lot on my words. I feel like I could have explained it a lot more simpler because I felt like you got confused at some points.
Mm-hmm.
It's like simple 5-year explanation stuff I'm really bad at. I do tend to repeat some my stuff myself a few times.
Mm-hmm.
As for code, maybe I could make it a little bit more language agnostic. So not use these return left or right. Maybe for the if not root or right is P or root is Q, I could separate that into separate if statements. Yeah, other than the explanations in that part of code, I think it should be okay. Maybe I didn't test enough in the test cases.
Okay, I'm going to say right now that I'm actually very surprised your code actually works. It actually is essentially correct. It's like it was so confusing because usually I get a little bit more complicated or a little bit more structured than this, but it actually is correct. So here, let me simplify the idea for you and what went wrong. So
okay.
it's like we have this problem as humans. It's like, oh yeah, we got the right result, therefore my process must be correct. And because it led me to the right result. But realistically speaking, the way you approach the problem is actually kind of dangerous and very risky because your idea itself wasn't clear and the step-by-step wasn't clear either. So let's go through this. So the first thing I noticed was like, okay, you're clarifying inputs, output. That's gonna be that's fine. But the first thing I noticed was that when you came up with these cases where you said left subtree, right subtree, well, it doesn't really matter if like P and Q is in the left subtree, right subtree respectively. Like because essentially, what you did here, I've highlighted it, It doesn't matter because it doesn't matter if like 5 and 6 or it's 5 and 2. Because essentially you're gonna be looking at both these nodes anyway for a recursive solution. So to me, this is like basically the same case. It's good that you have it listed out, but you shouldn't harp on it. The other one is that this both node in left subtree. Again, doesn't matter if it's in left subtree, right subtree, because what you're really trying to do is come up with a proof by cases that is bulletproof. What do I mean by this? So there are only a handful of cases that you need to handle, right? Where it's in one subtree or the other subtree. You don't need left or right subtree. It just needs to be one or the other, right? The second case you need to handle is if one is a parent of the other. That's it. Those are basically two cases you need to handle. I get you're trying to do that here, but you need to be able to express that idea much better because notice here, like I like this is just kind of, it's not only repetitive, it's also incomplete.
Yeah. Okay. Yeah.
Because if you're really going to go down this route of left subtree, right subtree, you need to also say if both nodes are in the right subtree, and more specifically, if both. And in fact, this is actually quite a misnomer. It's like if both in left subtree, I guess it's relative to the root, but then again, it's like, it's a recursive solution. What if there is like, what if I took out this 3, and I gave you 5 and 6? Then this explanation doesn't really make sense. So the bottom line is that I feel like you kind of lucked into the solution. This is like what we would call getting lucky.
Okay. Yeah. Okay.
So the way I would describe it is, let me write out here because it'll help. So you would need to handle cases of what's it called? One is in one subtree, other is in another subtree, and then what do you expect to get the output of this? And then return current node. You need to specify how do you handle that case, right? And then it's like one is a parent of the other, return the parent. So you need to specify what you expect to get in, what you expect to get out. And examples are meant to support this. So.
Okay, yeah.
Okay, so once you have that, next thing. So you tried going to it by traversals. The thing is that, I get why you're trying to do it. It helps. But I'd rather you organically grow the problem and then figure out the traversal as well. What you did was try to go from traversal and fit it into the problem. And yes, technically you will use a traversal because it's a tree problem, but it's better to try and figure out how you're going to solve the problem, then fit it.
Okay.
So this is what I would suggest, because then you probably define like how your structure and your traversal is actually going to go. And so you kind of said you were waiting for the go-ahead. No, you're the one leading discussion. It's not like the interviewer himself is not there to babysit you. You're a big boy. You're responsible for leading the discussion. So when you want to go ahead and code it, you go ahead and code it. So this is where writing out the ideas actually helps, because then you understand what you're trying to do at each step. So this is like where the discussion of pseudocode comes in.
Okay.
And I think for now, doing this is going to help you organize your thoughts. So you see, like with M and Russell, I made them do this for a while, and then after a while, they were able to wean themselves off of it because they were able to properly define their ideas. So I want you to do this for now.
Okay.
It might take a while, but like hopefully you can get rid of it by Google. So okay. So the next thing you said, oh, should I define the class? Like, well, this is not a difficult class to define.
Yeah.
So you should just go ahead. It's only taking like 10-15 seconds. So the only time you really skip writing classes is if it's very, very difficult to write it.
Okay.
Yeah. So the next thing is remember, for recursion, you need to define what you're getting in, what you're getting out. So if you do the pseudocode for this, then I think you come up with a pretty different structure for the code. But again, it gets you the answer. So in this case, you should have defined what the function puts in, what you expect to get out, and what it represents. Okay. And so another thing that was pretty bad was you don't know average time complexity.
Yeah, I have no idea. Oh.
So
yeah, I don't know how to do average time complexity. Well, I have an idea, but I'm not sure if it's the right idea.
Okay. let's actually try doing this. So what is the maximum? So you said that the maximum time is like order n, right? Because we could possibly traverse through everything, right?
Yeah.
But the average case scenario is just defined as what happens if I just traverse through the structure and I find it at an average rate. So let's do this. Let's do this exercise, right? So how far down would I recurse in an average scenario for traversal?
Down to a leaf node, maybe, or well, down to P and Q. Well, down to either P or Q. If you traverse down. Okay.
Okay. Actually, yeah, no, wait, wait, let me, sorry, my brain is like fucking not working right now. Sorry, repeat that?
So, what was the question again? So, average time, what happens, when we, on a average case, when we just traverse down the route?
Yeah, so let's say that in a normal binary search, let's take a very simple binary search. So, what's the runtime of that?
Runtime of binary search should just be log of n.
Yes, correct. And so if I'm right now, because this is not defined as a binary search, we are going to be iterating through every single node, essentially, to try and get it, because we don't have like a definitive. Oh, we can, when we go down, we can prune half the elements.
Yeah.
So because of that, that is going to be order n. Now the reason why I made you do that, even though you got the right answer the first time, is because I wanted you to make sure that you were actually capable of actually parsing this problem yourself.
Mm-hmm.
So that's the point here. It's even though I like pushback, like, are you sure? Try again. Like, just I wanted you to make sure that you actually knew what to do. So basically, the idea is that okay, left side, I'm going to be traversing through the node. I can't necessarily prune anything out, so root log of n. I'm almost on average going to have to look at half of the nodes anyway, so that's going to be order n.
Okay, so yeah, basically what you meant was, so we're gonna have to go down the left subtree anyways. That's order log of n.
No, that's the height, but at the end I might have to. So let's say, for instance, on average case, let's say I pick 6 and 0, right?
Yeah.
For the tree, 3, 5, 6. Okay, well I have to go back up to 5, but in a log n situation, usually I'd be able to cut out this 108 subtree, and then I'd be able to cut out this 247 subtree. Instead, I actually have to traverse it in order to try to find the 0. Like, on average, I picked any 2 nodes around here. I'm going to have to try traversing through quite a bit of nodes. Even if I pick 6 and 4, I'm traversing through half the tree.
Yeah.
So, okay. Anyway, so the point here I want to drill in your head is the clarity of the thoughts that you have. That's really important. So, if there's anything you take away from today, I want you to be able to define what the cases are, how you're going to solve the problem step by step with the idea, then pick the traversal, because like, what if I give you a tree problem that doesn't have like a clear structure to it? I mean in general, you're gonna have a traversal that's just like a little shortcut, but this is you just abusing the fuck out of the shortcut. Normally I'm okay with, but when we're just starting out, then I kind of want you to have some clarity of idea here.
Yeah, for sure. Yeah.
Okay, and then finally, I want you to be able to test your idea after. I want you to be able to simulate the stack with this. So once you're done writing it, I want you to be able to like test your happy cases, test your edge cases. What can go wrong here?
Okay.
So really do the pseudocode, do the test cases, and then follow the clarity of idea, and be able to. And once you have that clarity of idea, you'll be able to explain like your 5. So I want you to write it out, okay? Don't do things in your head. I think you're gonna have the same problem. Don't do things in your head. All right. Let me give you another problem, and hopefully this isn't one where you've memorized the solution.
Okay.
Okay, IP address. Yeah, the IP address problem. I think you might have seen this one, but I'm going to give it to you anyway. And this time, but I want you to really try applying everything we talked about.
Okay.
Okay, so I want you to compute the valid IP address. So what we mean by this is that, let's say I have an IP address, but the dots were missing, right? And so this string of letters or numbers can actually represent these following IP addresses. So 190.168.122, 190.168.12.2, blah, 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 blah. What I want you to do is, given this string of integers, I want you to return back to me all the possible IP addresses that this could represent.
Okay. All right. Okay, so basically, compute all valid IP addresses.
Yep.
So yeah. I'm guessing. This is IP version 4. Then I guess. So what
Yeah.
actually defines an IP address?
Yeah, sure. Assume that we're not doing some IPv6 crazy shit. So it just sounds like you're familiar with the rules of an IP address. So
I mean, I only know that there's IPv6 and IPv4. And there's weird stuff with IPv6. I'm not exactly sure what defines IPv4. I know I usually when I see IP addresses, it's just like three numbers and then a dot in between. I don't really understand how much. I think for two, it basically had to add up to 255 in binary.
yeah, between each of the subnets or whatever it's called is between 0 to 55. Correct.
Yeah. Okay, so they have has to be 255. I'm guessing it has to be 4 dots for sure then.
Okay. Yep. Yeah. You have 3 dots actually.
3 dots. 3 dots. My bad. Oh wait. Well, three. Sorry. What did you say?
3 dots. You have 4 of these. You have 4 of these numbers separated by 3 dots.
Yeah. Okay. Yeah. And they have to be the numbers has to be equal up to 255. So valid IP addresses for this number. I noticed that 1.90, 1.16. I thought I have an extra number. 122. How come this isn't never mind, I noticed why. There. Why how come this isn't a valid IP address?
What? Which one?
The one I just typed out. Like so cuz I'm trying to figure out the rules of
That is actually a valid IP address. I only gave you like a few examples here, so.
Oh,
But the
okay.
leading, for now, let's make it interesting. No leading zeros for now, because in theory you could have leading zeros, but it's just for the sake of convention. Let's say no leading zeros.
Okay.
Actually, no. Actually, you know what? Let's keep it simple. Let's keep it simple for now, because your code should be robust enough to be able to handle it if we decide to throw that in. So.
Okay. So, yeah. So this automatically strikes me as some sort of permutation thing. Let's go for your.
I want you to be able to do it step by step. I know you probably memorized a lot of solutions. I want you to at least come with clarity of idea.
Yeah, for sure. I can tell you for sure. I know nothing about this question, so going at it blind.
Yeah, do it. Let's do it the way we've been doing. I kind of told you to. So
yeah. So cases. Let's figure out what the possible cases for computing valid IP addresses.
How would you go about testing your code, and what do you need to do to ensure complete coverage?
How would I go about testing my code and ensuring complete coverage?
Yeah, because the reason why is because how would you structure this? How would you go about doing the problem, and how would you test it?
Okay, how would I go about? So first thought, just place a dot at every possible time, how do you say time point.
Okay.
Place a dot at every possible point. Possible points you can calculate calculated by current digits, current number. Let's just do digits. Current digits being processed. Being under 255. So what I mean by that is when I process, I go from iterating left to right. If I see a number less than 255, then put a dot right after it, essentially. So it'd just be like one, for this test case, it'd be just one dot.
Okay.
Do the same thing here until I run out of dots.
Okay.
So, but that would be pretty, bad because I'd end up with this kind of thing. So that would be kind of bad. That would be kind of bad. But I think if we're doing some sort of brute force, if we're not comparing about complexity or anything, then I can just have another check at the end, like right after I configure the digit, check if it's valid, check if created IP address is valid, check if it's valid by splitting, partition would probably be a better word. Partition string on the dot character, then convert each number to a int and check if it is below 255. Yeah. Oh, also, yeah. That should check. That is a check if created IP address. I don't think we need this check then if we're iterating from left to right. If the number, no wait. I think I see some redundancy already here. Because I'm checking twice again if it's under 255. Technically, it should already be under 255. So I could just, yeah. Well, not redundancy, but I guess it would be a little bit of redundancy. So possible counts calculated by current digits being processed, being iterated from left to right. 255, 255, 190, 68. I think it could be a little bit clearer if I just generate all possible test cases and see if there's a pattern somewhere. So, but that would probably take very long with this amount of digits.
Okay, so you have an idea. You see a number. Iterate left to right. See it. Okay.
Yeah.
Okay. Check. All right. So at least you came up with the idea. I don't see how exactly this kind of converts to code, but I understand that you at least laid something out.
Yeah. Okay, yeah. I'm not really sure how it converts to code. I mean, I'm somewhat, I have an idea of how it can convert to code.
Okay, I want you to refine this step by step, the high level idea, so and then until it basically is one explainable to a 5-year-old, and if let's say a 5-year-old walked into this interview and could see it, they'd understand. The second is that it should be easily convertible. So.
Yeah, for sure. So yeah, okay. If let's check. So if current digit is under 255, then basically create empty string first. Just call it S1 for easy.
Okay, that's okay. Not quite
Not too
what I
much?
meant, but I don't want you to start naming variables. I want you to think of it in terms of general algorithms, like routines that you want to do.
Okay.
So the high level idea that like a 5-year-old can understand. So if you're gonna explain your solution to a 5-year-old, how would you do it?
Okay. Yeah. So if current digit, let's remove any ambiguity first because of this line over here, which I didn't really explain too well.
Yeah.
So yeah, place dot, well, period, after digit. Place dot after digit, so that'll be in this case 1.9. Yeah. Okay. Yeah, 1.9. Oh, I already have it here. But yeah. Okay. Place digit after digit.
Okay.
Increment. Place dots.
Sure.
Block by 1. So we only check if created IP address. If
this is effectively a counter. Why don't you just call it a counter?
You're right. You're right.
You need just a very simple language. Increment place dot. Like okay, but there's a better way of saying it. So it's like just say it's a counter or something.
Yeah. Increment counter of dot period. Yeah. So if counter of dot is equivalent to 3, because then we know, hey, this is an IP address. We don't know if it's valid, but it's an IP address.
Okay.
And then we partition on the string, and then we basically check. This is how we check if it's valid. So I can just like over here, just a side note. So yeah, current digit 255. I really don't think this check is necessary because if we process a single digit cannot be over 250 over a 2-digit number.
Okay.
So that check is kind of useless anyways. Yeah, so intuitively this makes sense to me. But I don't know if it's right.
Okay,
so
let's pretend, let's put on our I'm a 5-year-old hat.
Yeah.
Okay. So you're gonna iterate from left to right. Place a dot after a digit. Okay.
Yeah.
Increment counter of dots that you've placed. If the dots equals 3, then you check if the IP address is valid. Okay, is there anything else you want to do?
Record if valid, record IP address. And then at the end, return all recorded IP addresses.
Okay, so I'm reading this, and so all you've done here is place digits, iterate left to right, place digits, increment digits. If counter is equal to 3, which is not, and then you exit. So all you've done is just this. If I'm a 5-year-old, I'm taking all your words at face value. All I see is you've only placed 1 dot.
Yeah.
That's it.
What do you mean by placing 1 dot?
Well, I'm following your code exactly verbatim, the idea.
Yeah.
You said iterate left to right. Place a dot after a digit. Increment the dot, counter of dots, right? And so the dot is equal to 3. Well, it's not, so, and then I'm out, you know?
Yeah. Oh, well, we're still iterating from left to right.
But, okay, so when you
like
stop iterating, here's the thing, you just said iterate left to right, so I'm like, okay, so then let's it's like, this is not really that clear. Iterate left to right what?
Okay, left to right over given string. Would that be a bit better?
Sure. So you're gonna iterate from the left to right over given string. Are you gonna iterate over each digit?
Yeah, over iterate.
Over string. Okay. Well, now that it's a string, it's on each digit or characters. Like, okay, fine. Now it's a little bit better, but it's a qualifier that makes a difference. Okay. So now you're gonna iterate through every single digit. Now I'm gonna take your thing at face value, right?
Mm-hmm.
So now I put 3 dots. Eventually, loop, and then. I'm gonna iterate over the rest. Place dot after digit. Place dot after digit. Place dot after digit. So this is effectively what you just gave me.
Yeah, I see the problem now.
Remember, like a 5-year-old's gonna just take your shit at face value. You know, they're like fucking drunk. The intelligence of me is like I'm fucking drunk as fuck, and I have just walked in. You know.
Okay. Yeah. So now I'm seeing that maybe recursion might be a little bit better here.
Okay.
Basically, we recurse over every possible point, and I don't know. Okay, recursion to me, usually I'm thinking of we place it at every possible point, and then we basically place it at every possible point, and then we don't place it. We also have another case where we don't place it at that point.
Okay.
Does that make sense?
Sure, I get that. Now the question is, how do you want to write that idea?
Okay. Let me do over here. So, basically same thing over here. Iterate left to right. Create a set that puts dot period at current index.
Okay.
Create another set. I'll just create a set that does not put at current index. Yeah. Iterate over left to right. Create a set that puts dot at certain current index. Create a set that doesn't put dot at current index.
Okay, well, what do you
Uh,
mean create a set? I don't know
yeah.
what create a set means in this context, if I'm taking it at face value.
Yeah. Okay. Create a set just basically means we append the string to it. So we place it over here. That would be one set. Create a string. Would that make better sense?
Okay, so you're going to create a string. So
yeah.
you're going to create a whole new string.
I mean, I'd probably put it as an array sort of thing. String does make it a little bit really weird.
Okay.
But what I would do is, yeah, creating a string is very bad. So I could technically just put in an array instead. That might help. But
Okay,
then I
what
might
are you
have
putting in the array? Let's put it that way.
Yeah. I'll create a string. That's true. A dot and that's really hard to parse. A dot and the current places dot and current number being processed sort of thing.
Okay.
And current index and yeah, we essentially that just does like that does nothing. That just increments the index.
So you're creating a new string that has a digit and a not digit. So this would just be, if I'm taking this at face value, although I would recommend you rearrange this. You have one dot, dot here, and then you have just, actually this would be one dot. Sorry.
Yeah.
One dot, and then this would just be one.
Yeah.
Okay.
Yeah.
All right, now what?
And then as we go left and right, so this is essentially at least exponential because we're exploring every possibility. So in the next case, it would be 1.9 dot. This would just append 9 to it.
Well, write down your idea.
Yeah.
I don't know where this is coming from. Where in your idea is this coming from? You're making it up. Don't do shit in your head.
Okay, so create a string. Create a string that doesn't put up and appends number to string. Create a string that puts dot at current index and appends dot and number to string.
Okay.
So essentially this is recursive, so we explore every possibility.
Okay. So how do you want to do? How do you want to implement the recursion? What are the steps to do before the recursion, and what do you do after?
Say that again.
What are the steps? You're waving a magic wand right now. Recursion.
Yeah.
Well, what does that look like? I don't see no recursion. I don't see the idea written down.
Okay, so recursion as in we I mean, I don't really know. Recursion in pseudocode is a bit hard for me to.
It shouldn't be.
Yeah, it shouldn't be. I don't know how. Unless I call it function.
No.
I have to do a function call, but that's not really explainable to a 5-year-old.
Nope. Again, 5-year-old. If you can't explain it, you don't know it.
Yeah. Create a string that puts iterate from left to right, given string on each digit. Yeah. How would I do this How would I put this recursively? I can define it technically, but not.
All right, so let's define. Let's say you got a function, right? What do you expect to put in? What do you expect to get out?
What I expect to put in? I put in a. So I'll put in a string. This is just for the recursive function.
Sure.
I'll put in a string. I output a string without. Okay, no, here. String index. I'll put a string. I'll put 2 strings. One containing dot place at index and another not containing dot at current index, but containing a dot place at index.
Okay, so you're gonna output two strings, one that contains a dot
Yeah.
placed at what is that? Okay, at the index, and
Yeah,
another not containing a dot placed at the index. Okay, so which means that if I pass in function 1 2 3 4 5, and then I pass in a dot, let's say I pass in integer 2, then you would return back. Actually, let's make this easy. So then you would return back to me a pair, let's call it array 0 1 2 dot 3 4 5, and then you would get and 0 1 2 3 4 5. This is what you're telling me you would return.
Yeah, essentially something like that.
Okay. No, don't say something like that. You have to be clear in your
yeah,
ideas.
yeah. Okay. It is like that. It is like that. Yes.
Okay, so then, all right. So you're going to define this function, right? So then, how does your current? If you're going to use recursion, then this current function needs to be able to do that.
Yes.
Okay. So then, So then that means that. How I don't see the return here. So let's say you have a def function, string, and then index.
Yeah.
So what are you returning? What are you returning?
I would return a. I would create a string. Maybe I should have defined the return a bit more clearly in the beginning.
You return what do you expect to get in? What do you expect to get out?
I mean, it would essentially be something like this over here. You know, yeah, wouldn't it just be this just a little bit more clearly explained?
What is this? You mean this one?
The other thing I'm highlighting right now. I'll put two strings.
I don't see the thing you're highlighting. Can you bold it? I don't see it.
Okay. Over here.
Oh. So you're gonna. So yeah, this is output two strings, which is literally this. Which is this.
Are you highlighting something?
Yeah.
Okay, let me reload the screen. I cannot see you highlighting anything.
Yeah.
I see you underlined it.
I bolded it. There you go. So
okay, yeah.
Let's do that for now. So yeah, this is. I have just this here is an example of what you just said here.
Yeah.
So this is like what you would expect to come out. Okay, so show me how this function. Not only what your idea. How does this show this function, and how does this function get you closer to your answer?
So once I have all possible combinations, once all possible combinations are computed, then we check every single one to see if it's valid and only input the valid ones.
Okay, so your first goal is to generate every single possible combination of. Let's be clear about what you say possible combination. Possible combinations of what?
Possible combinations of dot being placed at every possible point in the string.
Got it.
Yeah. Then we record only valid ones. Valid ones is checked out by this over here.
Okay, that's fine. But then how does this function get you there? Because you can only return. You said that you only return two strings, and surely there's more possible combinations of putting the dots here than two.
Okay. We can have an array that record that outside a global variable, a variable outside the function that we append to that records all possible. That records all possible permutations, combinations.
Okay, so every single time you run this function, you just add it to a global list.
Yeah. We can prune that. We can make it a little bit smaller by only appending to it if we see 3 dots in it, in the string.
Okay. Sure. So then, how do you want to do that?
Like just we just define like a variable over here, like a global list.
Okay, yeah, you're gonna define a global list, but the thing is that now where is it in your idea that you're gonna add to it?
I guess over here, initialize a storage for all possible combinations of dot being placed at every possible point. Create a string.
But
and then
storage for all possible. You already have the global list. What do you mean? I don't know why you have this.
no. Oh no. That I thought it's why I put in more English words. Sort of
Okay,
thing.
I see. But I mean, you already have it out there, so you might as well just define it before you call
Yeah.
the function, right?
Yeah. So
just
over here and then I'll say that again.
So here, just put it out here, just to say you initialize global
Yeah.
list or whatever. But what I'm saying is that, well, you're running this function. I don't see you populating it.
Yeah. Okay. Let me get to that. So and then append both strings to. Let me check. Just more heart garbage at this point. Append both strings to global storage.
Okay, so you're gonna iterate right, left to right over given string. You're gonna put a dot and put no dot at the current index. Okay. So if I took your code at face value, what happens?
Probably takes a couple years to
No,
load
not
on
even. And then what's the problem?
What's the problem? It's not that clear.
No, it's clear. It's just wrong.
Okay.
Do you know why?
No, not at this point. Because it seems really, like, naive.
No, what I'm saying is that it doesn't even get you to what you want. Let's literally walk through your example. Let's walk through it step by step, and it should be very clear.
Okay.
So let me find the string. So, okay, 190.168.122, right? So let's say I have my I call this function. I guess you're starting with index 0. Well, what are you starting the index with?
Yeah, 0.
Okay, let's say 0, right? Iterate left and right over string on each digit, right? So you're gonna create a string that puts a dot at the current index and appends.
Yeah.
So let's say you put that adds the digit, digit and appends dot to a string and append both strings, right? So now you have 1 and 1 dot, right? So if I'm my global list, I have 1 and then 1 dot as my string.
Yeah.
1 and then 1 dot, and then now you're gonna iterate over the next digit. So right now. So we're looking at here, right? So now the next thing.
Mm-hmm.
Okay, now you're gonna have this. So then now you have and we're gonna do the same thing. 1 9 dot, and then 1 9.
Yeah.
Next, what do we have? Okay, we're gonna go to the next digit. Here, we're right here, right? So now we're gonna have 190, 0 dot, and then 190. Do you see where the problem is?
Yeah, we don't.
It doesn't even get you to your answer, so that's what I mean. Like, you need to be able to just walk through your code and your idea. You can't wave a magic wand. Prove to me that your idea actually works.
Okay. Now that you're talking about it, sort of a more simpler idea came to mind. I'm remembering grokking at least. For permutations, you could use some sort of BFS way, so we could utilize previous. We do something similar to this already. The current solution, but we iterate through the past arrays, the past entries we had already appended to our list.
Okay. Let's stop. Notice like how for the past 30 minutes you've basically been inventing it as you go along.
Okay, yeah.
Has that gotten you anywhere?
Not really.
So let's actually try and figure out how to plan ahead.
Okay.
So the core. Let's just walk through the example that you want to do, and generate what you expect. So let's say I gave you. Let's start over. 190.168.122, right? So what do you expect to do at each step? I have a string here. Yeah. What do you plan on doing?
A string. I would just. So like my basic solution that I already have
Your basic naive solution that anyone can understand that will solve the problem. Don't care about the runtime. Don't care about the space time.
Okay, so, I mean, I could just go, like, left to right. Once I see a digit that is under, no, okay. So once I see a digit under 255, I just put a dot over here. So
Okay.
168, 122. And then I would take the previous one, so one over here, maybe find another. If the next digit is that doesn't make it a 255, that makes it above 255, then we put a dot here. Similar thing with here.
Okay.
I don't think. Okay, I think I could do this in one iteration instead of. So yeah,
Just simple,
I go
a very
left.
simple solution. Stop complicating it. Just a very simple solution.
Okay. Left to right. As soon as I find a number that makes it above 255, I just put a dot in it and then move on to the next digit.
Does that get you all your answers?
No, that only gets us. Like, it's a sum, but not. Like, it was a valid one, but not all the valid ones.
Yeah, we want all the valid ones.
Yeah. You can try. How would we split it?
Okay, let's ignore the technical thing because I think it's confusing you because you're focused too much on that. In a magical world, if you could wave a wand and the code would follow you, what would the idea be?
Place a dot at every single. I mean, I would just probably place a dot every single possible place and then check if they're all valid.
Okay, put 3 dots in every single possible place.
Yeah.
Place every combination.
Yeah.
For every combination of 3 dots in every possible place, and then check the validity. And
yeah.
Okay, that's fine. So let's just do this for now. Ignore the fact that this is completely horribly inefficient. How would you do this? And that's the question. How do you generate those combinations of 3 dots?
Well, basically, 191, 168. No, okay, yeah. So I'll just place 1 dot first.
Okay.
Make the string. And then maybe I'll utilize the previous string that I already generated. So 190 here over here. Well, yeah. So and then over here, 168, 122.
Okay.
And then over here again, over here 168, 122. So that would be our first iteration.
Okay.
Placing every single dot. Try it again now with using 2 digits. 2 digits.
Really?
First,
is there other ways that you can exploit what you have here?
Okay, yeah, that's true. We can utilize. So first, we're at the basic level over here. We're just placing dot. First 2 digits. We can go back to the first one with 190, 168, 122. Place a dot on after 2 digits. So it would be over here 168.
Okay, I'm going to show it to you. I'm going to show you this. Why can't I just do this?
What do you mean?
Notice where I put the dot.
Over here? Yeah, I mean, you could.
So why are you starting it off here? Why this? Let me ask.
It's just because it was a 0. Like I didn't consider the actual value of the number.
Just assume leading zeros are okay for now.
Yeah.
Just assume that. And you said you already said try a combination of 3 dots in every single place.
Mm-hmm.
So why did you ignore this one?
Every single possible place. So I placed it at the dot after 0. You place it at the dot after 1. I'm not sure if I'm understanding it correctly.
My question is, why did you jump here? Are you just trying random dots?
Okay, so I basically meant as
what is the algorithm? Yeah. What is the step-by-step that you do? Are you just randomly? If you're just randomly placing dots, then you might as well use a random number generator and run it to infinity in order to randomly place the dots. So that's what it looks like.
Yeah. So I place it. I go placing dot after. I place a dot after every one single digit.
Okay.
I place a dot after every 2 digits. I place a dot after every 3 digits.
Okay,
4
but does
digits,
that
5
get you
digits until
okay,
we
so
get to
after
the
every 1 digit, 2 digits, and 3 digits, right? So then
yeah.
why did you skip this?
I didn't really consider 0. I considered 0 as just being like it's okay by itself sort of thing.
But you already made a commitment here. Do you see where doing shit in your head actually gets you into trouble?
Wait. What? I can't see what you're highlighting.
Oh. You made a
Yeah. Okay.
commitment to every single possible combination of 3 dots in every possible place.
Yeah.
And so you're saying, oh, well, now I'm omitting zeros. I'm going to do this. I'm going to do that. But you never told me that, and you are just doing this. You made a commitment, and you're doing
Yeah.
other shit.
Okay. Yeah. That is a good idea. Yes. I have skipped a few steps in my head, or I forgot about it. Yeah.
There you go. I mean, you verbally declared you're going to do this, and you're not doing it. You see how you
Yeah.
lose the interviewer.
Yes. Yes. I can totally see that. Yeah.
Okay. So let's
So
say
yeah.
for now, I assume leading zeros are okay. Now,
Okay.
does that change how you're going to do things?
Not really.
Okay. So what's the next number you're going to generate?
So over here, 1.9. It's already a little bit confusing. So yeah. We already have that over there. So 6 dot 8122.
Okay. Well, let me ask. Why did you pick that?
Just going off the previous one over here, we just
Okay.
moved the digit once to the right.
Okay. Sure.
Yeah, and then essentially it'd just be the same thing over here.
Sure.
We move it once to the right.
Okay.
Over here, once to the right.
Okay. I get the idea now.
Yeah.
Now, can you come with a general solution for this?
General solution. So, place periods right after. Yeah. Okay. Placing. How would I put that into code?
Mm-hmm.
So, well, it's more technically at least. Put a dot after. So once we process the current digit, place a dot after it every single time. And then, yeah, how would I put a dot at every single place? 1.90 dot. Iterate. Yeah, so we're going left to right, that's for sure. How to put this 190.01. 168, 1.9. So yeah, first of all, let's make it a little bit more clear for me at least. 1190, 16, 168, 122. That's the first 3 digits. But then, okay, I mean, my first case is we place 2 digits at the first possible place. So there's 192, and then we just shift the last dot right, until we're finished with the first 2 dots, and then we move the second dot to the left once.
To the left one.
I mean, to the right once. To
Okay,
the right once.
Sure, I get it. I get that. And then Then what?
And then once we're done processing all the second dots,
Did you
and then we'll
did you skip
repeat
steps?
we'll repeat the same process for 3 dots again for.
Okay, so show me that on this. Where's the next dot go?
Yeah. Next dot would be over here.
Okay.
Right, that's 3. Yeah. Oh wait, what? That's 3. Yeah, that's 3. Let's take it 1, 2, 2,
Okay.
and then 1.90.1 uh 6 dot 8 1 2 2. We just shifted one
Okay.
left
Cool.
once.
Do you think you
Yeah.
could write the code for this? I think you get the idea. Do you think you could write the code?
Yeah, probably, but I'll struggle a lot with it.
Why?
I'm not too familiar with how to put shift. If I get shifting out of my head, placing I plus, yeah, I think I can do it. Just placing a dot right after the digit. If we make an array or a string for every combination, then yeah. How do I explain this? Yeah, I'll place a dot after every digit, essentially. Append a dot to every array index.
Okay. Let me make this. I'm going to show you how easy this is, and then you're going to probably kick yourself for this. This just looks like 3 for loops to me.
Okay, yeah.
Well, you could just have 3 for loops.
That is true, yeah.
What is the complicated part about 3 for loops? Let me ask that.
I'll say that again?
What is the complicated part about 3 for loops?
Nothing, not really. 3 for loop sounds pretty simple, yeah.
Because if you look at this, all you're doing is just iterating. It's like you place the the dots at one index, and then the next dot at index plus 1, and then this one at the index plus that previous index plus 1, that previous index plus 2, plus index 3, 4, 5, right? And then you move this one from index to index plus 2, index plus 2, yeah, and then you just repeat the same process. It's 3 for loops. Because and then you move, eventually you get to a point where you move this one up, right?
Yeah.
So it's just 3 for loops. So so what you're focusing on is like how do I get the add the dots to the string? I would argue that the more important part is, well, figure out what your dots are supposed to be placed to begin with. Where do you put the dots?
Yeah, that's true. Yeah.
So, and once you have that structure, then you can fuss around with this. But it's like you're going in reverse. Like, oh, where do I put the dots, and how do I express this? And it's like, well, how about you figure out where you want to put the dots first before you figure out actually adding the dots to the string?
You're right. Yeah.
Like, well, I don't understand why you focused on, how do I add dots to a string? Because to me, it's just like all it is just string plus dot, or like string dot splice at 0 to x, and then plus dot, and then string dot splice from x plus 1 to n, or whatever fuck.
Yeah,
I don't understand why this is the part you focus on.
Yeah, I think it was a mix of me trying to make it a bit more optimal as I go along, before exploring the naive, we're skipping steps essentially.
Yeah. You made a commitment
yeah.
to do this. Go fucking do it. And then it's like you're optimizing while you're thinking of it, which is a really great way to screw yourself when you come time to writing the code. Because now you have two half-baked ideas.
You're right, yeah.
Yeah. So why don't you figure out how to actually generate the combination of 3 dots, then optimize afterwards?
Okay, yeah.
Okay.
Yeah. Okay.
So if that's the case, now that we've settled that, I want you to actually write the code for this, or at least the pseudocode.
Okay, yeah. All right, I'll just start over here then.
Yeah,
so,
I don't care if it's suboptimal. We already said it's gonna be suboptimal. We expect that. Just show me how you're gonna do it.
Okay. I have typed it in wrong. Okay. J.
Okay.
J plus 1 over here.
Okay.
Yeah, I plus 1 over here.
Anything else you might be fucking up on?
Yeah.
Okay, that's fine. Sure, whatever.
That's fine so far. I'm gonna initialize. Well, I have to initialize global array. String. Let's call S. Empty over here. Yeah. What am I doing? String I. Yeah, okay. That's current digit, plus a dot over here,
Okay.
over here. Okay. 3 for loops, but I need to.
Keep in mind, you're only grabbing the digit at one part, right? So what happens
Yeah.
if you end up getting into this situation with here? Now you're only gonna be looking at the 9.
Yeah.
See, like, just think carefully about it before you write the code.
Okay, yeah. Yeah, so yeah. Okay, this is the part I am a little confused about. So yeah, I get the for loops thing.
Okay.
We have to like create the string, but we also don't want to have previous iterations of the string affect the current iteration of the string.
What do you mean?
So we don't want our case of 1 9 over here, since we place a dot over here, we don't want it to affect how we place the dot over here for the first dot.
Okay, so why not just make a copy of the string?
Yeah, we can make a copy of the string. Yeah. So would we make a copy in the first inner for loop? Copy. No, that's kind of weird. No one does that. Yeah. Copy over here then. Copy our current string. But that already creates a new string anyways.
Remember, we're committed to creating every single possible combination.
Yeah. I'm just trying to figure out how to create one iteration of a string.
Okay, well, you said you're gonna copy this, so...
Yeah, so on the first one, we place a dot right at 1 over here. 1 dot. But then on this, if we do imagine the for J and K run perfectly, we have to think about placing the 9, but we have to place the 9, the dot after the 9, but remove the dot at the 1 currently.
Okay, but if you had a copy of the string, and you manipulate the copy and you threw it away when you're done, you don't have that problem.
Yeah, but if we copy it, how do we? Well, what do you mean by copy? I guess like
A
you
deep
mean
copy.
just copy like this? Yeah, I know. Decopy, but would it just be like a decopy like what I wrote over there? Because if it's like that, then string I. What do I do?
Let's put pause because you obviously don't know what this is even doing.
Yeah.
Put a pause in it. So,
okay.
The problem you're facing is that you are modifying the original string. And you are afraid that when you go into the next iteration, that you need to edit this dot. Right?
Yeah, I need to move that dot to the right.
What I'm saying is that if you added this dot on a string you can throw away, you don't have to worry about that. Does that make sense?
Yeah, isn't S currently we could throw it away after? I think S, yeah. I meant for S to be thrown away after. Because we're initializing it inside the I for loop.
Okay. So what is the problem if you already initialized and copied it?
Because currently we're only copying the string at index I.
Okay, so what do you need to do?
Probably just S. Copy S over here. Just have a different. No, we already have S as the original copy. String as the original copy.
Why not just copy the range string from was it 0 to I?
Yeah.
Why don't you do that? let me ask, why did that not occur to you?
Cause I am dumb. I don't know. I don't know why that occurred to me. That
It's a
seems
very
really
logical
simple.
series of steps, right?
Yeah.
You said, I don't want to be able to add the dot and then remove the dot. And I've literally told you, why not just copy the range you're interested in? Copy the string you're interested in, right? So
Yeah.
the way to copy the range that you're interested in is just this.
That is right.
It's
Yeah.
not, you're overthinking it. I literally just told you what to do. All you have to do is just write the code for it. And you would agree that this would have solved your problem.
Yeah. I don't know why that didn't come up. Yeah.
I literally told you what it was. You just have to do it.
Yeah.
That's the way these interviews work, and these problems. They're all a series of logical, simple steps.
Mm-hmm.
So.
Yeah. Okay. So. Oops. Yeah. So, you're right, and I essentially do the same thing with the 4J and K.
Mm-hmm. So then, how do you want to do the code for that?
Yeah. So now that we have S, S, which is the copy of the string of a string plus the dot at the I index, and now we essentially can create another copy of string of S, but place the digit at.
Why do you want to copy S?
Okay, maybe not S. We don't need to copy S. Because that has a dot we are concerned about with the first one.
This is right now at this moment. It's one dot. Now, what do you want to do next?
Append every string up to index J, I to J. Include. Yeah.
What's the next step? Don't think ahead. Just what is the next step here? You have this one dot.
Yeah.
Here, sitting here.
Append the next dot.
To where?
Index J.
Okay, so how are you gonna do that?
Yeah. S plus equal string J plus dot, but that doesn't make sense. We need to do something similar to the 0 to index I.
Okay.
That's for sure. So, because over here we have I, yes. I plus 1 to J. Oops. Yeah, okay. I plus 1 to J. Because then we copy over. Yeah, we use I plus 1 to J, because then we copy over. Because the for I loop covers strings up to I, and this covers strings up to J, and we place a dot. And then we do something similar to K.
Okay.
So
then what do you need to do here?
Yeah.
So you're just continually appending to S.
Yeah. Yeah, so that's not exactly good. So that copy thing. I know it has something to do with that copy thing. Plus equal. Okay. So the plus
if
equal.
If you append, you have to get rid of it.
Yeah, I think we can just do S equal. No.
But then now you're overriding the previous S that you got going.
Yeah. So.
What's the thing you need to do now?
I mean, an idea that I think might work is just this. Though it doesn't seem very nice.
Well, let me throw an idea. Why don't you just create another copy and then join it all at the end?
Okay, yeah. So another copy of S.
Or you just call it T or whatever.
Yeah.
Okay. I'm starting to see where the problem is, actually.
Okay, yeah.
In other words, you basically have this 3 loops ideas, but you basically just come up with random ideas, but you don't think of what the implications of that idea are.
Okay, yeah, that does sound pretty accurate.
So, in other words, let me do this. Maybe this will help clear things up. So what if I showed you? I'm going to show you how I would do this problem based on this naive idea that you have, and maybe this will help you. So
Okay.
let's say I'm going to start with a loop at indexes I, J, K, right?
Yeah.
Loop through the string from 0 I to length of string, which you got going, right? So you at least got this part going. I, and then this one will go to I,
Yeah.
I plus 1, comma J, and then, this is a J plus 1,
Yeah.
and then K, right?
Okay.
So then I'm going to then grab the chunk of numbers between 0 and I. And we'll call this chunk 1, right?
Okay.
And we'll just make we can make a copy, like a new object if we want to, right?
Yeah.
So then let's do chunk 2, right? Between I plus 1 and J. Let's say 0 and I, right? And then this one should actually be 1. And and then after that, just for the sake of correcting things, right? And then chunk 3, grab chunk of numbers between J and then K.
Yeah.
Right? And so now I have my 3 chunks, right? But I need 4, right? So then let's just say that there's an L here. So now I'm going to say K plus 1 to L, right?
So the fourth chunk is. So what does the fourth chunk do exactly?
So the fourth chunk is if I go through 190.168.122, then it's going to be.
Yeah.
Let me copy and paste this down here. So I need to have this is 1 chunk, 2 chunks, 3 chunks, 4 chunks.
Oh yeah. Okay. Yeah. Yeah.
Okay. And so now I have those 4 chunks between K and L, right? And then if chunk 1, 2, 3, and 4 are all valid, then global list add chunk 1 plus dot plus chunk 2 plus dot plus. You get the idea.
Yeah. Okay. That sounds a lot clearer.
Does this make sense? Let me first ask.
Yeah, that makes sense.
I mean, it is kind of resembling code, but notice that even a 5-year-old who walks into this fucking interview, has no idea what's going on, understands what's going on.
Yeah.
And do you understand how this idea transforms into code?
Yeah, I think that I think I might encounter some bugs as well implementing it, but that's the fault on my own, not the fault of the pseudocode.
Right. And the pseudocode is very structured, very easy, very difficult to fuck up.
Yeah.
So this is more important than whatever your thing is going on up here.
Yeah.
This is what I've been trying to get you to do, for the past, 30 minutes. Literally, what is the top level, high level idea that will get you to the answer? Don't worry about, the fucking copy shit later on. Fill it in when you need it. And once you realize, and you go through the code, you realize, oh, wait, I need to copy whatever the chunk is. That's when you deal with it. Yeah. But you getting confused over these little nitpicky things when you're we call this expression, seeing the forest for the trees or whatever the fuck it is. You're paying attention to this one little tree that may or may not actually be, there at the end, but there's an entire fucking forest you need to deal with.
Yeah, that's definitely right, yeah.
So, if you take away anything from today, focus on the macro level idea you know is going to get you to the answer. And start very simple. Commit yourself to that and execute on it. Then improve on it.
Okay. Yeah. Yeah. If we were to, would we iterate over inefficiencies? Because I don't really see any at the top of my mind. Is there any for generating this?
Oh yeah, no, there are. There are plenty. I mean, well, for one, you're using 4 loops, right? Second, you can optimize for a chunk validation, and third, the interviewer wouldn't like how messy this code is.
Yeah.
Writing four nested loops in code is pretty ugly to me.
Yeah, it is pretty ugly. Yeah.
So you can always optimize it, but in general, you would want a recursive solution.
Yeah.
Okay.
Recursion would probably be better. Yeah.
Yeah. So what I want, and I really want you to try and drill this into your head. Get the idea, top level idea working. Even if it's super naive, and then and then improve upon it. All right. So we're gonna do since with the time remaining, let's do one more problem. We're gonna do something very simple, and I want you to focus on doing the pseudocode and the high level idea of it that anyone can understand, even if they walked into the interviewer, even though like a fucking drunk ass 5-year-old looks at the board, can read that shit, and it's like, oh, I understand what this guy's doing. I mean, granted, they probably can't read. They probably have ADHD or some shit and can't read that much, but you get the idea.
Mm-hmm.
Okay. Okay. Validate a binary search tree. Very easy.
Okay.
Actually, you know what? You're pretty proficient with trees, actually. So I think that's kind of or I don't know if you memorized it, but actually, it really doesn't fucking matter. I want you to give me the top level idea and be able to describe it like this. You know, be able to describe the high level idea to me.
Okay.
And write that shit down. Nothing in your head. If I have to ask you where this idea comes from, you basically lost already. So.
Okay, so, a valid binary search. Oh, okay, you already defined it.
Yes.
So a valid binary search tree is defined as follows. So the left subtree contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both left and subtrees must also be binary search trees. Yeah, that's so yeah. So basically, from what I understand, so a certain traversal called in-order traversal will
don't start. Remember what I said. Don't start with in-order traversal, pre-report order. Don't start with the idea, the grounds up. Don't throw random traversal at it, because I could possibly say, oh, why not use breadth first search?
Yeah.
So I want you to start with the idea first. How are you going to validate a binary search tree to begin with?
So since it's on the left, so left subtrees must be less than key, right subtrees must be greater than key. So
okay,
essentially,
did you memorize this solution or not?
I don't memorize it, but I know the general idea. I know
I know you know the general idea, but I want you to put it in the terms of how we discussed it.
Yeah. Okay. So high level, basically.
How would you do this? Yeah. Step by step.
Append all. Get the leftmost nodes. Get leftmost nodes. How do I describe this? Cause okay. High level solution. Okay, how do I explain? Okay, so I need to explain in-order traversal because that's essentially how I do it, like a really not optimal way.
Mm-hmm.
But it is a valid way for binary search trees.
I want you okay. So let's say let's roll with it for now. But I trust that you're going to explain the idea very simply.
Okay, so in-order traversal, I just define it as left node right. Property of in-order traversal is that it creates a sorted order of a BST.
Okay.
Sorted order as in sorted ascending order, not strictly ascending, but just ascending. Not strictly ascending though.
Okay, fine.
So yeah, it creates a sorted order of a BST. So essentially what we would do is perform in-order traversal tree recording every node visited.
Okay.
After every node is visited, then after iterate over recorded nodes left to right and see if it is in sorted order, as in neighboring. Okay, that goes more, maybe a little bit.
That's fine.
too
I
into-
get it. Record and see if it's in sort of order. Okay, that's fine. I get it.
Yeah.
This is pretty simple, pretty easy to understand. I get what you're trying to do. That's fine. Now,
Okay.
you would argue. Actually, let me see if you can write the code for this. Now that you got this idea.
Okay, sure. Code for this idea. So this requires a helper function. By the way, so in order. Okay, that's not a good way to do it. You want so valid BST. That's a better name for it. You give me the root, which is the root of the entire tree. So I would initialize a global list. So I should have specified that earlier.
Okay.
Sorted order tree. In order list, I guess, to make it a bit simpler, because we don't know if it's sorted or not.
Okay.
Yeah. And then in order, that's going to be a function. Yeah.
It should be off the top of your head, man.
Yeah, I know. Yeah. My bad.
Go.
Yeah. So
just go.
Okay. So yeah, list, root. In order, we pass it root. Pass it in order list. So basically, we do our check. You know, the basic in order. Null. Oops. If left to right. So yeah. Basically in order root dot left. In order list dot append roots.
Okay.
In order list dot append root dot right.
Really?
Yeah. Oh, my bad. Not. Good catch. So yeah, that's it. Return. Okay. Now over here we check in ascending order. So basically for iron range land in order list. Let's do 1 over here because we're gonna be checking the neighboring.
Sure.
We're just checking neighbors to see if it's sorted.
Sure.
So if in order I minus 1 is greater than in order I return false, then after return true.
Okay.
For that.
Cool. So that was pretty fast, right?
Yeah.
You had a pretty clear idea. You know what to do. You had executed it.
Yeah.
Yep. So, and that's what I want you to do for any given problem. And if you don't know it off the top of your head, you can at least build up to it.
Okay. Yeah.
You basically went in with you knew the idea. You went in with almost no hesitation. Because you were pretty certain of the idea, right?
Yeah.
Yeah. So that's the feeling you should get when you're doing any problem. And if you don't feel it, then eventually build up to it. Gather the pieces you need, and then be able to prove it. Okay? So now, you would agree that this is not the most optimal solution.
Yeah.
Okay. So let's make it more optimal. How do we do that?
Essentially, instead of we can still utilize the fact that in order traversal creates a sorted ascending order of a BST, but we, instead of appending it to a list and then checking it, we can do it as we traverse through the list. So if the previous node encountered is less, if the previous node we encountered is bigger than the current node, then we return false immediately.
So the previous node encountered is the bigger node, but what do you mean previous?
In order for traversal, so over here, it is a bit difficult. So essentially, we're simulating this in order traversal code, but with a stack.
High level idea. Ignore the fact that you've written code. High level idea. Pretend I'm a thumb sucking 5-year-old.
Okay. We use the previous node. So when we traverse down a tree, there's gonna be the first node you encounter, and then as you traverse down a certain path, there's always gonna be a previous node that you got to the current node from. So we just compare those two nodes. Okay.
So, in this case, let me look at the tree. So based on what you, let me bring a tree as an example. Hold up.
Yeah.
So let's say I have this tree, right? So you're
Mhm.
saying we're gonna compare 3 with 5. Oh wait, this is not even valid. Hold up. Actually, I need to come up with a freaking good tree that has. Fuck. I need an example of a valid binary search tree to make this like even remotely good. Fuck it. Let's use this for now. So you're saying that I'm gonna compare 3 with 5, and then
Yeah.
5 with 6, and then 5 and 2. How would you do this?
Okay. Oh wait, how to do this in code or just like explaining
step by
it?
step. Step through it for me.
Okay,
No
so
code.
we're on node 3, right?
Okay.
That's the current node. Previous is null. We don't do anything. In order traversal goes left first, so we go left. So it's 5.
Okay.
Now we compare 5 and 3. If 5 is okay, so if 3 is bigger than 5, then done. It's false. Not really good.
I would recommend you write out your idea, by the way, since you're pretty
Okay.
certain. So the pseudocode for it anyway.
How do I put this in pseudocode?
Yeah.
So, keep track of previous node.
Okay.
At every iteration, I guess you'd call it iteration.
Sure.
At every iteration, compare current node being processed with previous node.
Okay.
Compare by checking if previous node's value is greater than current node's value. Whatever apostrophes. If previous node is greater than current node, then return false for all possible. Like, just return false, stop it. I'm sure if I do like actual code, it'll be a bit simpler, a bit more complex than that. But yeah, if that's go to, if that's return false, after, and then we keep on iterating. If we never encounter a return false, then we would just return a true.
Okay, that's fine. Seems like you have an idea. Seems like that works. Why don't you code it up for me?
Okay, I will try. Yeah. Is it okay if I just modify the? I'm just gonna call.
I mean, you can. I feel like it would throw you off, but feel free to do whatever you want.
Yeah. Okay. Yeah, you're right. That probably will throw me off. Okay. Just over here. Yeah. Okay. In order list. So we need a stack because we need to implement in order list. Same thing. Don't really care. So yeah. In order previous node, we don't really need a list. Previous node. That's just gonna be null first, so no one really cares. Previous, yeah. If previous equal null, then previous equal current. No, you know what? I don't even need to do that. So in order root dot left.
Well, you said you're gonna check.
Yeah.
Well, remember what you said you committed to.
Yeah. Any variation. We do our checking here. So compare by checking if previous node. Okay. Maybe I explained that a bit wrong. We need to traverse down to the lowest value first.
Okay, that's fine.
Yeah. Traverse to lowest value BST first. Yeah. We need to traverse to the lowest value of the BST first, and then previous. We set our previous roots, and then if pre dot value is greater than root dot val, return false. Though that's not gonna work in recursion, so I would probably just set is valid 1.
Okay. You see where the problem is?
I did not think too clearly ahead.
Yep. So that means that what you want to do is be able to step through this example step by step.
Yeah.
Anyway, I think we have 10 minutes left. I kind of want to I want to talk a little bit about homework and stuff.
Yeah, for sure.
But yeah, there's going to be a problem. I want you to do step by step, and I want you to be able to keep I want you to do this like homework and just kind of let me know how things go.
Yeah, for sure.
So
Yeah.
Let me bring up a practice diary. Give me a sec. Okay, so I'm actually going to use a copy of what M's practice diary is, because I think he took pretty meticulous notes, and I would like for you to try and emulate it. So let me go ahead and send this to you. Where is... Yeah. Here you go. So let's call this your practice diary, right? A few things I want to point out, actually.
Okay, let me get into the practice. I need access to it.
Okay, sorry. Let me open up the... Okay, try again.
Yeah, that's good.
Okay, you can kind of scroll through this and see, oh yeah, like as you get down to like past row 120 or so, you can see like how he basically times himself and then looks at the differences between the EPI solution and his solution.
Yeah.
You basically need to do exactly the same thing.
Walk through every step how the EPI solution does it at every step and how I do it at every step.
Yes, and say, okay, this is what they do, this is what I did, here is what I need to do in order to be able to get to the book solution. So
okay.
Feel free to make another sheet, but this is giving this to you as an example of like how you should try and record yourself and keep track of your mistakes. So really, I would recommend looking at the stuff he wrote later on past like row 180. I think that's when we basically did a lot better.
Okay.
But yeah, this is meant to give you ideas of like how you can nitpick your own mistakes.
Okay, for sure.
And you notice here, like, hey, here's the ideas that what I should have done. Here's what I did. Here's what I shouldn't have done. Here's how I'm going to do better next time. So this is going to be what your best friend for the next few days, or next few weeks.
All right, yeah.
Next
I'll
thing.
definitely.
All right, next thing, homework.
Study this. Yeah.
So prep doc. So I'm back at the prep doc right now. 519. So basically, everything we talked about today. 1, don't do shit in your head. 2.
Wait, prep doc. Do you mean the second link you sent me?
I think I sent it to you already. Yeah. So the second link, yeah.
Yeah, I need access to that too.
All right, let me share it. Okay. You should have edit permissions done. Go ahead.
Yeah, I have it. Yeah.
Cool.
A minute.
Don't do shit in your head. Explain like I'm 5. Plan your code beforehand. So this is where the pseudocode comes in. And then test your code step by step with examples. So these are the 4 things I want you to focus on whenever you do these problems. So and then also like if you planned it, commit. So these are things I want you to focus on. And from everything we talked about today, the core problem I saw was basically that you, like I said, you did stuff in your head and you kept trying to go through it, and then you basically patched and prayed. You want to plan so well that you don't have to do that.
Yeah, you're right.
Okay. And so for homework, I want you to do everything we talked about with recursion. But I want you to do it with a EPI chapter. So let me go ahead and bring that up.
Okay.
There should be a corresponding one. Okay. And also I would highly recommend for your recursive functions, define what you put in, what you get out.
Okay.
Because I definitely see you struggling trying to explain recursion, but which means that you probably don't understand it either. So I'm going to say chapter 16. In my book, it's chapter 16, but there's a chapter on recursion.
Okay. Okay, yeah, chapter on recursion. Wait, what? Oh, never mind. You used, yeah.
I mean, I have the Java version, so.
Yeah. Okay, yeah.
But I don't think, I think it's going to take you a long time. I really want you to drill this, and I don't want you to look at the answers until like at least give yourself 30 minutes.
Okay.
And I
30
really want
minutes
you to
at least.
like once you run out of these ideas.
Okay. So 30 minutes of just like designing, you mean, or like including the code too?
Of designing before you give up. Give you the problem 30 minutes, and I really want you to like try these steps.
Okay.
And it helps so you can watch old sessions with M as well. I think he has pretty much the exact same problem.
Okay.
At the beginning. So go ahead.
Yeah, go first. Oh no. So I was saying so for steps 1 to 5, this does not include code at all. Then so just straight up like talking about it. Let's do the pseudocode step 3.
Yeah. We're focusing
Like,
on planning, making your planning as simple and clear as possible.
Yeah. Okay.
Is all we want to get done with today. Because once you have the plan, then you can write the code for it. Because if you plan correctly and you explain it correctly, the code will be blindingly obvious.
Yeah.
Right.
Okay. Yeah.
So this is the homework for now. Let's just after stream, let's call and talk and touch base a little bit more about this. But basically, this is like all the stuff I want you to focus on. I don't think you're gonna run out of stuff to do. There's plenty of things to do here for recursion, and then afterwards probably binary trees. But I think recursion is gonna be your best friend for now.
Yeah.
Okay. Anything questions about what we talked about today?
No, I think everything's good. Yeah, time to do a lot of homework, sort of thing. Recursion on chapter. Yeah, I do tend to skip a lot of steps. That's pretty good that you pointed that out. But yeah, nothing really much right now.
Okay. All right. Cool. I'll call you after the stream. We'll chat a bit more. All right.
Yeah, for sure.
All right. Sounds good. Talk to you later.
Talk to you later.
Okay. All right. Any questions from the stream? It's a little bit late. It's midnight. Thanks for hanging out with me. His code and his walkthrough don't match already. Pretty much, yes. Should be explore the left-hand side to validate. Then we can compare to the previous to current. If valid, just validate the right-hand side. Yeah, there's it's a little bit more to that. But the point I want to drill in his head today was basically to just make sure that, hey, if you have some areas where you don't know exactly what the step-by-step looks like, you might want to like dive deeper into it and show a step-by-step for the idea. The question is like you can have a high-level idea, but then you also need a step-by-step for that as well. And the answer is actually there's a few bugs in that as well, Mr. Mystics. So, is there any questions from any other questions from the crowd? I'll give it a minute or two. Going once. Going twice. Yeah. So just to answer Crow Sue's first thing, is Jay a new student? Yeah, it's Jay. R is a what's it called he's off at Google right now. So, you know. All right, I guess that's it. No, would you mind going over the earnings worksheet from Owner of Nothing? I was hoping to fill out my own situation, but having a hard time understanding the formulas. Okay, sure. Let me bring that up. Let me get the link out. What the fuck? Okay, cool. Well, actually, you know what? Let me pull up the sheet. I can't get it through my blog for some reason, so let me earnings worksheet. Cool. Okay, so yeah. So for those who don't know, we're gonna be talking about a engineering blog that I wrote. It's called Owner of Nothing, and you can find it on my website echantech.org. It's a little bit late, but I'll quickly go over it. So basically, the idea here is if we compared your salary based across multiple different companies, and we said, oh yeah, like if like here's your salary, and then here's assuming that there is a 10% growth rate versus a 20% decay year over year. This would basically calculate the difference in your total compensation between the two companies given various scenarios. So the question Mihai Nikolai has is, would you mind going over the earnings worksheet? I was hoping to fill it out for my own situation, but having a hard time understanding formulas. So the blue numbers are what you're going to fill out. So this means that the growth rate just means, okay, by how much does the stock increase or decrease year over year? Your grant are your annual RSU grants in terms of stock. The base salary is cash salary, and we assume it's going to be the same for both companies. And the initial grant is just the initial sign-on for the stock. This is true for, I think, did I say it's true for both companies? I think so, yeah. Anyway, so this first scenario covers a high growth company that has that has 10% growth year over year, and that grants you $150,000 in stock every single year. And then this one here grants you $150,000 in stock every single year here. This initial grant is assumed the same on both companies. And then promotion grants. So this is what they give you if you get promoted. So let's say by year 4 you get promoted from junior to mid-level, right? They're gonna refresh you so that way your number of stocks basically matches up. So and this is the dollar value amount of it. So in this case, there'll be 1.2 million stretch over 4 years. So which means every single year they're going to give you extra $200,000. And then the promotion grants means that, okay, well, this is your new annual grant now that you're promoted. So, and so these are the numbers that are in blue are the ones that you are going to manipulate. And so this yellow here is basically going to be, okay, how much total difference in total compensation do you have after these scenarios? So in year 4, let's say you get promoted. There is a $100,000 favor. You actually make more in 4 years by $100,000 at the high growth company for a company that grows at 10% year over year versus a company that decays at 80% year over year. And this is assuming all these numbers hold true, that you make $100,000 more at the high growth company after 4 years. But if you get promoted, you basically earn more at the decaying company by $212,000. So hopefully that kind of explains how to use this sheet under various scenarios. So the worst case scenario is, like, let's say you go to a decaying company with no promotion. You over 8 years, you make $653,000 more at the high growth company. And yeah, you can plug in these numbers to your effect. So I think it's a little bit late. It's past midnight. So I'm going to shut off the stream. I'll announce later when I stream, but thank you all for joining me. Follow me on Discord to know when the next stream is, or just subscribe. I appreciate subscribers. If you all want to be coached, feel free to go to echantech.com and book me for interview coaching. Other than that, thank you all for joining me, and I will see you next time.